coming back to 1.7, and we had actually stopped at page 8 of our handout, which was example 6 is where we need to get started. So remember, the last thing we had actually talked about were these inverse properties for our trigonometric functions. And remember, we said as long as the value of our x is going to be within the domain and range for the inverse functions, we could go ahead and use these properties that composition between the sine and arc sine function, or cosine arc cosine, and tangent arc tangent could come out to be the value of x as long as you were within the domain and range of those functions. And these were the examples we had looked at. So now we actually want to get into how do you evaluate composition of functions when they are not inverse functions, right? So here you've got tangent composed with the arc cosine of 2/3. So this is actually where, and this is again coming from the algebra side of things, we are using what we call as U substitution. So the inside function, the arc cosine of 2/3, is what we are going to take and say, okay, let that value be equal to U. So this is where we're making our U substitution. Now remember from last time, when you have U equals arc cosine of 2/3, that means the cosine function is what we're going to take on the other side, right? And you would get cosine of U equals 2/3. So that's the idea we actually need to use here. So you're taking the inside composition, which is the cosine inverse or the arc cosine, setting it equal to U, which gives you cosine of U equals 2/3. Now we know the range of the arc cosine function or the inverse cosine function is between 0 and pi. And this is actually on page 4 of your handout if you need to go look at it, where we talked about the domain and range for all the inverse functions. So the range for the inverse cosine function is between 0 and pi. This cosine of U that we just came up with is a positive 2/3. So if you're going to be a positive cosine function, and we know that the range of your inverse cosine goes from 0 to pi. So think about it again. Let's do a little coordinate here. So if you've got x and y, we are saying the range of a cosine function is going from 0 to pi, and cosine is positive, so 0 to pi would be between these values, right? If cosine is positive, this is where we have positive cosine, positive sine, and this is where we have, what is our cosine in the second quadrant? Negative, and sine would be positive, right? Now, even if you think about, well, if we're talking about the range, you can also think of it in this sense. With the y-axis, it's still going to be the same exact thing. The only place where your cosine function is going to be positive is right here in quadrant 1. So that's actually the idea that we're using here to figure out where we need to apply this property at. So you're going to be in the first quadrant. So using that idea of first quadrant, we're actually coming up with our right triangle. Now remember, your central angle is always going to be starting from that origin. So using that idea of our central angle, we are saying if U is our angle, and we've got cosine of U equals 2/3. So cosine would be adjacent over hypotenuse, right? So that's where they're putting those values of 2/3. Using the Pythagorean theorem to have calculate the opposite side, right? Which is coming out to be square root of 5. So once I can use that idea of the U substitution to come up with our angle information, then we can fall back to that SOHCAHTOA calculations again, where tangent of U is going to be opposite over adjacent. So if this is my angle U here, opposite is square root of 5, adjacent is 2, and you get your value of square root of 5 over 2. Same thing is happening in that part B, where you have cosine of arc sine of -3/5. So again, we're going to take this arc sine of -3/5, set that equal to U, which means sine of U is going to be -3/5. Now we have a negative sine. The range of the sine function actually goes from -pi halves to +pi halves. So again, think about it. your positive pi halves is going to be right here, right? Going counterclockwise. No, sorry, going clockwise, we would have negative pi halves here. So that means we are saying between this is going to be the range of our inverse sine function, and sine is negative. Now we know in the first quadrant, sine is going to have what sign? SY, SIGN, sine. What sign does the sine function have in first quadrant? Positive. And in the fourth quadrant? Negative. So that's why, since we know that the range of the inverse sine function goes from negative pi to positive pi, in the first quadrant, functions are going to be both positive. Since my sine came out to be negative 3/5, that means this has to be a quadrant 4 angle. So that's why we are now drawing our triangle in quadrant 4. Again, this is our central angle, so that will be u. Sine function is opposite over hypotenuse. So the opposite side is -3. The hypotenuse is 5. Again, using Pythagorean, calculate your third side of the triangle. And then cosine function, of course, is adjacent over hypotenuse. So that's adjacent over hypotenuse 4/5. So you want to use that same idea to try and see how we can come up with our cosine composed with the arctangent function at -3/4. All right, so cosine of arctangent of -3/4. So the first thing, of course, is taking that arctangent of -3/4 and setting it equal to u. And then using our idea of the inverse functions, you would have tangent of u equals -3/4, right? Now, what is the range of the inverse tangent function?
The sine or
Our tangent.
oh, tangent.
Our tangent, yeah.
Oh no, the range
Range.
is negative and positive pi halves.
And are you including those endpoints? No, exactly. So you're actually it's the same values as your arc sine function. The only difference is you don't include the endpoint. So again, if you think about this in terms of your unit circle, you are again going from negative pi halves to positive pi halves, just not including those endpoints, right? And if you get tangent of u is a negative value, what quadrant are you going to be in? Yeah, because in quadrant 1, both sine and cosine are positives, which means tangent will also be positive in the first quadrant. In the fourth quadrant, sine is negative, so that's what's going to make your tangent a negative function because cosine would still be positive, right? So tangent function is positive in quadrant 1, but tangent function is negative in quadrant 4. So this is actually going to be a quadrant 4 angle. So U is a quadrant 4 angle. All right, so just like you saw in the examples, we'll go ahead and do our little triangle. He does not want to let me draw. Here we go. Oh, because the range of the tangent function only goes from negative to positive pi half, so it's only going to be this side. So So that's why both quadrant 2 and 3 are out of our range. Okay, yeah, very good. So quadrant 4 angle, if we draw our little right triangle, again, it will end up looking something like this. Again, your central angle would be your angle U. So now we are told that tangent of U is -3/4. So remember again, tangent is opposite over adjacent. So opposite would be -3, adjacent would be +4. So using that, we need to calculate our hypotenuse. So using the Pythagorean theorem, what do we get for this side?
5.
Yeah, because you're going to do 4 squared plus -3 squared, and then you would actually have to do a square root to find the missing side. Yeah, very good. Very good. So you get your calculation of 5. And then all that's left to do is go back to the original function that you started out with, which was cosine of arctangent of -3/4. So that would be cosine of arctangent of -3/4. We replaced that arctangent with u. And that's, of course, adjacent over hypotenuse. So that comes out to be now, just be careful about where you put that negative sign in this value. Can you tell me why we put the negative on the 3 and not on the 4? Because that would make a big difference if that were ever to change.
Y is going to be negative.
Why? Yeah, because that's your sine function, right? Remember, sine is the value that's negative in the quadrant 4. So that's why we had to put the negative on the opposite side instead of the adjacent side, since the opposite would be the sine value, which would be negative. So yeah, be careful about where you end up putting that negative sign. Okay, what questions, if you have any, about this example or the two we just saw before this? Any questions, Sydney?
Yeah, it looks like I'm here, like, what do you do with arc?
What do you do with arc?
Yeah.
Arc is basically the inverse function. So remember how in college algebra we had talked about inverse functions where addition would be the inverse function for subtraction, square would be the inverse function for square root. So in that same sense, when we are talking about I guess I don't really have those notes here, but so when you're talking about like cosine of theta, its inverse function, we actually write it as cosine inverse. Remember, we use that little -1 notation. So instead of writing it this way, we actually write it as cosine inverse. But the other terminology we use is arc cosine. So it's actually the same thing. And you will notice on your calculators, you have those little inverse functions, right, above your sine, cosine, tangent functions. So that's actually what these functions are talking about. So when you're talking about the arc cosine, you're basically saying it's the inverse function. So whatever cosine will do, this guy will undo that.
Oh, okay.
So that's what this actually means. And it's going to be the same thing for your sine. So the sine function would be sine inverse, or you can call it arc sine, right?
Okay.
And tangent would be the arc tangent. So they actually go back and forth in using this inverse notation with that -1 symbol, or they will just call it arc tangent. And it looks like your textbook kind of goes back and forth just depending on examples on those, but they're the same thing.
Okay.
Yeah?
Yeah.
Alrighty.
Thank you.
You're welcome. Anybody else have any questions on this? Okay, so these guys are actually going to be somewhat similar. But here they're asking us to just write the equivalent to each of these expressions. So here they're telling us sine arc cosine of 3x, and they're restricting the value of our x between 0 and 1/3, including your endpoint. So let's look at that part first here. So they're saying, okay, start with that u substitution again. We're going to take the inside composition arc cosine of 3x and set it equal to u. So again, using the property of inverse functions, cosine of u comes out to be 3x. Now again, think about it. What is the domain of the arc cosine function?
That's 0 and 1, right?
Because the domain of arc cosine is the range of the cosine function.
-1 to positive.
-1 to +1. Very good. So that's actually where they're getting this value from. So when they are saying that arc cosine of 3x, that means this domain of 3x has to stay between -1 and 1. So remember, that becomes the range of the cosine function, or it's the domain of the arc cosine function. So again, we know cosine can be written as adjacent over hypotenuse. So you can just write that 3x as 3x over 1. And then using that same idea of the right triangle, and this time you don't have to worry so much about quadrants. You're just going to take your right triangle, make one angle as your angle u. So that's going to be adjacent over hypotenuse, 3x over 1. So the adjacent side would be 3x, the hypotenuse would be 1, and then again use your Pythagorean to calculate the missing side. And then based on that, just like we did in the previous example, then you can do sine of u, which would be opposite over hypotenuse, and that's where that 1 minus 9x squared is coming from, is that opposite side over the hypotenuse of 1. Now in part B, they are still using that arc cosine of 3x, right? So that inside function is the same for both of them. So once you have that triangle calculated, you can apply it to part B. Part B is cotangent of u. So cotangent is, of course, the reciprocal function of tangent. So it becomes adjacent over opposite, which is where you're getting your 3x over square root of 1 minus 9x squared from. And of course, you still have that restriction on the x, where it has to be between 0 and 1/3, including or not including the endpoints depending on your function. So thinking on that same terms, let me see what you guys can come up with for number 7. Pretty much the same idea that we did for example 6, and you looked at example 7. This guy is secant of arc tangent of x. So you know, one of the big things you should see as a difference between example 6 and example 7 is in example 6, they gave us a specific numerical value for our angle, right? They gave you -3/2 or 3/4 or pi/2 or, you know, whatever. In these examples, they're giving you 3x as you saw in example 7, or they're just giving you x, right? They're not defining what the angle is. So that's how you know those two functions are going to have two different answers when you come up with. So start with your u substitution for the inside function. So if u equals arctangent of x, using your inverse property, what do you get? Very nice. Tangent of u equals x. So again, we know the tangent function can be written as opposite over adjacent. So that would become x over 1. So use your right triangle here again. Let's say this is angle u. So your opposite side is x, adjacent side is 1. So what will be the hypotenuse then?
1 minus x squared.
No. Think about your Pythagorean theorem again.
the square root of 1 minus x squared?
Why are you getting a minus?
I don't know.
Plus, yeah, because you're adding opposite plus adjacent sides, right? To get the hypotenuse. If you were given the hypotenuse and finding one of the legs, that's when you subtract.
Okay.
But you're actually finding the hypotenuse, right? Yeah. So that's why it's going to be either, okay. So that's going to be x squared plus 1 squared. And then you take the square root to get the hypotenuse c, which just comes out to be square root of x squared plus 1, right? You wouldn't be able to go any further than that. So this side, it's going to stay that little expression. Okay, so now we know, using this triangle, how can we come up with that secant function value? So again, you can write that as secant of u. And how do you define the secant function? 1 over cosine, which will become, yeah, very good. So just invert the SOHCAHTOA or the ka part, right? Adjacent over hypotenuse will become hypotenuse over adjacent. So what does that come out to be? Yeah, because your adjacent side is 1, right? Yeah, so it just comes out to be square root of x squared. That's 1. Anyone have questions on that part? So here you're really falling back to everything that we learned in that first part of this chapter, 1 through 4. Alrighty, so that would be the end for section 1.7.